For modern games, AI navigation is a must, whether it be for the player or NPC, hostile or friendly. Somehow you need to move the characters from one place to another. The go-to package for Unity is Unity's AI navigation package. These are the basics of how to get AI navigation set up and running in your latest project. Let's hop straight into a new Unity project and get to work. In Unity, the first thing that you're going to have to do is head up to the window, Package Manager, Unity Registry. You want to make sure that you have AI navigation installed. If you do not, make sure you install it and let Unity recompile. Now that we have AI navigation in, if we head back up to the window, down to AI navigation, it'll bring up this menu for us. I like to put this over here next to my inspector. There's a little bit of information in here. We have the agent types and we have the area types. We'll get into this a little bit later once we start talking about the agent, but it is useful to me to have that already open. Now, the first thing that we need to do is designate the area that the AI is going to walk around. For that, I'm going to create an empty game object, and I'm going to call it Y positive. There's a reason I'm doing this. For now, all we need to really care about is that the AI surface that's going to be generated is going to be with relation to the Y up axis on this game object, or the green arrow. If we go ahead and add the nav mesh surface component onto the game object, we'll see that same menu that we saw in the navigation window. If we go ahead and bake, and we will notice we have a blue mesh on top of our scene here. This blue area essentially represents the area that the AI is going to be able to walk on. In the nav mesh surface component, we have a couple of options that we can change. First off is the type of agent that this is for. This is the first window in the navigation one, which is the agent types. Here we have the default, which Unity provides, which is humanoid. It gives a bunch of default parameters here. We can go ahead and create, a different one. Let's call it, giant. And we can make this guy a little bit bigger. We can make him a bit wider, and we can make him, a bit taller, essentially. That's all great. We can keep the step height proportionally the same. So if we're doubling everything, then this would become 1.5. If we're doubling everything, then the max slope should stay at 45 degrees. The drop height, we can just leave the same. It doesn't really matter. Not in this scene, but maybe in your scene it does. The next drop-down menu that we have here is the default area type. If we come back to the navigation menu and we go to the areas tab now, we'll see all the different areas that we can have. If we go ahead and create a different one and call it, mud, we can change the cost of it. This will refer to how much the AI thinks it takes to move through this area, aka how much the AI wants to avoid this area. And we change over the default area from walkable to mud, and we hit bake. We'll now notice that the color is all pink. For now, we're going to leave it just as default walkable. The next value we can change is called generate links. Generate links is useful for objects that we have like this, where you have multiple layers. If we turn on generate links and hit bake, we'll notice a whole bunch of things come here, and we can see that these are essentially drop points, which allow the AI to drop down from this level. Or you can see over here, we have the same thing, but we also have jumps between the two obstacles. I'm going to turn those off for now, and then rebake it, and they go away. There's a couple of other options here, but I'm not going to go into detail with those because those are more advanced options. Great, now we have a surface that our characters can walk around on. But I don't want my characters to be able to walk on this obstacle here. They're obstacles. They're not meant to be walked on. If we go ahead and select these and go to the Add Component menu again, there's a different component called the Nav Mesh Obstacle. By adding that and enabling the Carve option, and now if we rebake this, now we'll notice that you can no longer walk on those objects, but they can still walk around and give us the nice space. Great. Now, back to the mud area type that we had before. These areas are meant to signify how much the AI wants to avoid or how much the AI wants to go towards those area types. You can essentially think of it as if the AI is trying to walk from its current spot here to over here, there are essentially two paths, the straight path or the around the side path. Currently, because this area is all the exact same, there's no difference, so it's just going to go straight. But let's say that this obstacle here in the center, which is stepped down a little bit, is actually just like really thick mud, hence why I call the area mud. We can add a nav mesh modifier. This allows us to modify how the nav mesh system takes this object into account. If we override the area and change it to mud, go back to our surface and rebake, now you can see that the area is mud. With the fact that the mud area has a cost of 3, the AI is now going to walk around this mud rather than walk through it. Unless, of course, the target point that it's trying to reach is within the mud. We can also do this with a area. If I go ahead and create a new object and call it area, let's go ahead and reset that to default. Just move it over here some. If we go ahead and do the nav mesh modifier volume instead, we'll see this game object here with this bounding box. If I bring this down into the mesh a little bit, and I change this to mud, and then rebake, we'll see a very similar effect to what the other one is. This one is you can define area, while this type of component does it based on the game objects, and you can also see all the children of that game objects. Our character here, notice how we carved out an area that you can't walk around the character, but the character is going to move, so now we're going to have a hole in this nav mesh here. Well, rather than doing an obstacle for things that don't move, we can do a modifier again. But rather than having the add or modify object, we just remove it. Now we can bake, and now that area you can see is gone, because this is going to be our moving guy. Of course, a mover can't be a mover without a nav mesh agent component on it. This has a whole bunch of values in it that you can change and mess around with, but the basic rundown is this first section is what type of agent we have. If I go ahead and enable this game object here, I just made a larger version of it. I do the same things and hit remove and add the agent to it. This is an agent. You can see if I turn off the capsule here, you can see the cylinder collider that represents the agent on the inside. That obviously does not represent the full scale of our guy. So instead, what we need to do is go to that giant agent type that we made before. We do that, and we change the radius to match accordingly. Now we have the same agent. The next set of options on the nav mesh agent is talking about movement, so how fast it moves, how fast it turns, how fast it accelerates, that sort of thing. Then we have obstacle avoidance, which I'm not going to touch really in this episode, except obviously to make the capsule bigger for the giant. And then the last one is for the pathfinding. These will be important later, so I won't get into them now. The last component that we have left to cover provided by the AI navigation package is the nav mesh link. I go ahead and create a new game object here and add a nav mesh link component. Let's reset the transform on that, and let's do, let's put this at 12.5. Let's zero these out, and let's do 6 and -6. Let's do 10, 11. Yeah, that works. Let's do 7 and -7 just to be safe. This will allow us to connect different parts of a nav mesh or connect two disjointed parts of a nav mesh. So say there was a wall here and there's no way to get from the main platform over. or if there was a pit and it was completely disconnected. This would allow an AI to get from one side to another. There's a bunch of different parameters in here, including how we edit the start and end points, as well as the width. So now the AI can move from any point along the width across to this side. We also have the ability to mark it as bidirectional, or only one way. The last thing that is really important, in my opinion, is the area type. I like to make my links a different area type, either a jump for something like this, or a drop if it's coming, say, from up here down, because I like to be able to customize the behavior there. We'll get into that when we start making our AI script, but for now, I think it's just important to set this to a jump type. With all those components out of the way, that's all great, but how do we get our little red dude over here moving? Well, we need a script for that, unfortunately. So let's go ahead and create a new C# script. Let's call it, I don't know, simple agent, and open our code editor. I'm going to go ahead and delete all of the code that's provided by Unity. I'm also going to add a required component type of nav mesh agent. This will make sure that this can only go on components with the nav mesh agent. We're going to expose a couple of fields here. So we're going to do serialize field, private float. We're going to call this nearest point search radius. I'm going to set that to 0.5 initially. Then we're also going to expose a layer mask for our raycasting. Raycast mask. We're going to set that to everything by default. In case you didn't know, the tilde0 is shorthand for everything. After that, we're going to have one simple private member, navmesh agent agent. Great. Now we're going to create our awake function. We're just going to get the navmesh agent on the current component. Next, I'm going to create the update function. I'm going to use the old legacy input system for simplicity's sake, but if you're going to be adding this to your new project, it's 2025. I recommend using the new input system. Just a fair word warning. But if we go if input hit mouse button down of the left button, we're going to cast a ray from the main camera. Dot screen point to ray input dot mouse position, and then we're going to raycast. Along that ray, we're going to get out a raycast hit. Then we will cast the ray for mathf.infinity. We'll do the raycast mask that we expose in the inspector. And then just to make sure, we'll do the query trigger interaction and just make sure it's on ignore. If we do hit something, we're going to create a new method called move2, and we're going to go to that hit dot point. Not move towards, move to. And if we go ahead and create that method, this is going to be very, very simple. All we're going to do is do if nav mesh dot sample position of the point out a nav mesh hit. We'll call that hit. We'll plug in our nearest search radius here, and then we'll do nav mesh dot all areas. That way we will search all available areas, and then we'll just do set the agent destination to hit dot position. Simple as that. Now back in Unity, if we hit play, we can see our AI guy is gonna walk around now. If I just go ahead and bump his speed up a little bit, we can see him move a little bit quicker. We can see him walk around. We can also notice how he goes around the mud pit, because it is actually better for him to go around than to go through due to the cost of the mud. Unless, of course, the point that he needs to be in is in the mud pit, in which case that's where he goes instead. So you notice he also navigates around said obstacles, just like we would expect. However, if we come down here to where the link is, and then move across, if I go ahead and do this, if you hit Control-Shift-F on while selecting the main camera, camera move to your current position, you can see him perform the link across as well. That is excellent. With just that, our AI works perfectly. There's no more that we have to do to get this working. However, I want to discuss a few more things and add a couple of additions to our simple agent script just to improve upon it just a little bit and make it a little bit more customizable for future use. Now, back into the simple agent script. I think it'd be really good if we can handle our links ourselves. As we saw, it was very jittery, it was very unsmooth, it was very uncharacteristic of any sort of natural movement that you would see of a character in a game. So I think it'd be really good if we can handle those links ourselves, so that way we can customize that behavior. In order to do that, we're going to need two more private members. The first one is going to be Boolean, and we're going to call it is following off mesh link, and we'll set that to false. Next is going to be a private component, nav mesh owner. I'll explain what we need this for later, but we're going to do a simple get. We're going to do agent dot nav mesh owner as component. Simple. Now, in the update method, we're going to do a simple if to check if the agent is on off mesh link, and we're not following that off mesh link. That we're going to do is we're going to set the off is following off mesh link to true, and then what we're going to do is I'm going to create a method that handles the link. Handle link agent dot current off mesh link data. Wonderful. We're going to generate that method, moving down below the move to, and format it as I like. This is just going to be a simple method that is able to delegate to different coroutines based on the type of link that we're following. And we're going to determine that based on the area type of the link. And I just change this to be called link data instead real quick. Now, first we need to check if the nav mesh owner is in fact a nav mesh link. So we're going to check if it's not a nav mesh link, then we'll just give it a simple debug.log error and say current owner is not a nav mesh link, and then we'll just return because we cannot follow a link if we're not on a link. And then what we'll just do is we'll just start a coroutine, and we'll just call it follow off mesh link, and instead we'll just pass along the link data. Then we'll have generate our new enumerator. And it needs to be enumerator. There. Perfect. The first thing that we're going to have to do in this coroutine is do agent.update position, set that to false, because we're going to handle our own position. As well as agent.update rotation equals false, and agent.update up axis equals false. Then we're just going to get a simple vector3 end position. We're going to call that link data.end position. Then while vector3 dot distance between the transform position and the end position is less than, say, methf.epsilon, or you can do, I don't know, 0.001f or something like that, whatever you want there. What we're going to do is transform.position is vector3.move towards the end position. I have an extra p in there. We'll do that based on the agent's speed. So that way we can change everything based on the agent, nav agent in the inspector, and then we'll do a yield return null. Then after the while loop, just to make sure that we are absolutely at the end position, we're going to set it to it. Then we have a little bit of cleanup to do. All we got to do is following off-mesh link. We're going to set that to false. We'll agent.complete our off-mesh link transfer since we are doing it manually. Then we just got to set all those three update position, update rotation, and update axes to false as well. There's one more thing that I like to do. In the await function, I'm going to set the agents.auto traverse off-mesh link to false. Since we are now handling it ourselves, we want to make sure that we don't have to set that to false every time we create a new agent in the inspector. Just do it in the awake function, and then we don't worry about it anymore. I made a simple error. This needs to be greater than here in the while loop, because you want to wait until they actually reach there. Then speed our guy up again. Keep forgetting to do that. Move him down. And now we can see he goes across the link. Currently, this is no different than what we had before. However, by putting it into this follow f-mesh link coroutine, we can now completely customize how this is going to behave. We can change the transform's rotation, we can transform the position, we can put it into a arc so that way they actually move vertically as well. One last thing that I want to do real quick is if we go into the handle link method, rather than just always starting this coroutine, first I want to check link.area nav mesh.get area from name, and let's say jump for now. And then what we'll do is we'll move this up into that if statement. The reason I want to do this, and I'm going to change the name of this here really quick to jump. The reason I want to do this is while we're back in Unity, like I said before, what if we wanted to handle a drop from, say, this platform differently than how I wanted to handle this jump? What we can do is if we're in the areas, we can do a drop area type, change that to, say, I don't know, 0.5. We'd rather drop down from somewhere than have to jump. If you go back into this script, what we can do is essentially copy this method signature, just close it really quick. I'm not going to actually implement this. This is up to you guys to do. We'll call it drop. I'll just actually, what I'll have to do is yield return null, just so it doesn't give me the error. And instead I can do an else if here. Looks like it's going to do it for me. Don't need the else statement, but the else if works for me, so we can just start the coroutine for the drop instead. So now we can handle the drop differently than the jump. According to Unity, you shouldn't do a cost less than 1. So I'm just going to put that back up to 1 for you guys. But I hope you guys learned something this time. I hope you guys understand something that you didn't quite before. And I hope you guys are able to take what I've shown you and do something new and exciting with it. But that's where I'm going to leave this basics of AI navigation video off. Next time, I'm going to be going into a little bit more advanced detail with it and how it works with 3D movement, how we can walk on walls, how we can walk on ceilings, how we can transfer between those different surfaces. I hope you guys enjoyed, and I will see all of you guys next time.